Hello, this is Mr. Pruitt, and today I am talking about Newton's first law. This is the second part of a series on forces for my high school class. This one will be specifically talking
Alright,
about
so
static
let's review real
forces.
quick.
First thing that we know is that forces are balanced when opposite force pairs have the same magnitude. So like when we're looking at this chair, the downward force of gravity on the chair and the upward force, the normal force provided by the floor, have the same magnitude. Now, when all the forces on an object are balanced, the motion of the object is unchanging, like this chair. And sometimes we call this a static state, and those forces are considered to be static forces. Another example of balanced forces would be the cruise control in your car, where we're going at the same speed all the time, where the force, the applied force going forward, and the drag force going backward are equal to each other, which allows us to maintain a constant speed. So today, when we're talking about first law, so when we look at Newton's first law says that objects at rest remain at rest, and objects in motion remain in motion until acted upon by an unbalanced force. Sometimes this law is called the law of inertia. So what is inertia? Well, there's this mistaken idea out there that inertia is a force, and inertia is actually not a force. Inertia is a state, and it can be most easily defined as an object's resistance to changes in its motion. So if an object is at rest and you want to make it start moving, the amount of resistance it puts up to you putting it in motion is its inertia. So when an object's motion is easy to change, like it's easy to make it turn, or it's easy to make it speed up or slow down or to start moving, then we say that it's easy to overcome its inertia, and we say that it has low inertia. It's in a state of low inertia. And whenever an object's motion is hard to change, like it's hard to turn, or it's hard to speed it up, or it's hard to slow it down, it's hard to make it start moving, then we say it's hard to overcome its inertia, or that it's in a state of high inertia. Alright, so the first law describes what happens when all the forces on an object are balanced. And then it also describes what conditions would have to be met to change the motion of the object. So when all the forces are balanced, things that are at rest stay at rest, and when all the forces are balanced, things that are moving continue moving in a straight line at a constant speed. And if we want to change that motion, then what we need to do is we need to apply an unbalanced force to it to cause the change that we want. Now, since first law describes balanced force situations, the net force has to be 0 newtons. So if you look at our bowl of fruit over here, that's at rest. The net force on the bowl, or the net force on the fruit, has to be equal to 0. Also, because these things are just sitting there in the bowl, it implies that these objects are not accelerating because there is no net force on them to cause them to accelerate. So what motions are described by the first law? There's only two types of motion that are described by the first law. The first one is objects at rest, like the books in this bookcase. All the forces on these books are balanced. The normal force, the gravitational force, and any lateral forces on these books are balanced, and so they stay in the same spot. Or if we have objects that are moving at constant velocity, like this asteroid moving through space, it is generally, because there is nothing to add to create a force on it, it is generally moving at the same speed. So how do we solve first law problems? Well, here's the algorithm. First thing you need to do is just draw the free body diagram like we've been practicing in class. Then, if there's any vectors that are on an angle, we need to resolve them so that we have a vertical and a horizontal vector. Finally, set up your equations based on the free body diagram. And we'll be practicing this in class, and I'll put some Pixie clips out for that. Then, since the net force we know is equal to 0, we're going to set our equations equal to 0. Finally, we're going to solve our equations, and that's going to give us whatever answer we're looking for. Thank you. I hope this has been helpful, and have a great day.